Hello everybody and welcome to another exciting science lesson with Mr. Foster. Today what we're going to be doing is looking at how we can extract some copper sulfate crystals from a solution. Now what we're going to do is two types of separation technique. The first one is filtration. We're going to look at how that works, and then we'll move on to evaporation and crystallization. Firstly, filtration, it works by separating an insoluble substance from a liquid. So we've got some copper oxide here. Now that is insoluble, doesn't dissolve in water. And we're going to be reacting that copper oxide with sulfuric acid. Sulfuric acid will react with the copper oxide to form copper sulfate. And then what we'll do is we'll filter out any excess copper oxide so that we have a nice clear copper sulfate solution. Once we've got that solution, we will then use evaporation to crystallize the copper sulfate. So what we're going to do first is react the sulfuric acid with the copper oxide. Now obviously we're dealing with an acid, so while I'm doing this I will be wearing a pair of stylish goggles. What I'm going to do is measure out 25 milliliters of sulfuric acid. Now this is an irritant. It's not a concentration that is going to burn holes in me, but it is an irritant. If it were to get on my skin, it would cause an itchy rash. If it got on my eyes, obviously it would cause a lot of harm. 1 molar solution, so it's enough to cause harm to my skin, cause a bit of itching. I'd want to wash it off, but it's not incredibly strong, so the reaction is not going to go forward very quickly. What we'll do to speed up the reaction is use a water bath. Now the water bath, I'm just going to use a kettle, boil some water up and pour it into a beaker, and then I will place the reaction mixture, which will be in this here boiling tube, into there just to warm it up. That will give the particles more kinetic energy, and so they will have more successful collisions in the reaction, and the reaction will proceed at a faster pace. The first thing I'm going to do is take my sulfuric acid, which I've just measured out, and pour it into my boiling tube. I am then going to place the freshly boiled water into the beaker to form our water bath. That's going to start to raise the temperature of the sulfuric acid. Obviously taking care not to get that on my skin. I'm not going to handle the beaker at the moment because it's going to be quite hot. What we'll do next is we'll take our copper oxide. You'll notice is a black powder, and I'm going to add this to my sulfuric acid. So when this reacts, there will be quite an obvious color change. You can see a black powder. At the moment it's floating around in that sulfuric acid. If you look very closely, you'll see it's beginning to change colour. Now that colour change is caused by the salt which is being formed, and you can see there now all the black colour has pretty much vanished. There's a little bit at the bottom there, so I'm going to give it a little shake, get that to mix up a bit more, but that blue colour, the salt that's being formed, is known as copper sulfate. The copper comes from the copper oxide. That's what the Cu stands for, copper, and O oxygen, copper oxide. And the sulfate comes from the sulfuric acid. Whenever you react a metal compound with sulfuric acid, you create a sulfate, and copper sulfate is this beautiful blue colour. Now as you can see, there is still some black powder at the bottom. Again, I will be giving this a swirl every now and then. What we want is for all of the black copper oxide powder to react with the sulfuric acid. We need the sulfuric acid to be fully reacted, because the second stage of this experiment involves evaporating all the liquid away to leave behind the salt as crystals. Now, if there was still some acid inside that boiling tube, sulfuric acid would evaporate, I could inhale it, and it could damage my lungs. So I have to make sure it is fully reacted. And to do that, what we do is we add the copper oxide in excess. Now what in excess means is you add more copper oxide than you need. If there's more copper oxide than you need in the liquid, it will react with all of the acid, leaving none behind. Now you can see there's a tiny bit of copper oxide powder still left in there, so I'm going to add another spatula of copper oxide powder just to be sure that all of the sulfuric acid has been reacted. So I'll pop that in there, and once again I'll start swirling it. Now I'm up to my 6th spatula of copper oxide powder, and as you can see, it does not seem to be dissolving anymore. It's no longer reacting. There is still the blue color you can see in the background there, but the copper oxide powder that remains in this liquid is insoluble, and so it's just floating around inside there. It's not reacting, it's not turning into that lovely blue color. So what we'll do is we'll move on to the filtration. Now filtration relies on a piece of filter paper, which I'll fold in half twice. We've got a conical flask there, which will be nice to sit our filter paper in. And we take our mixture here. Remember, this now contains no sulfuric acid. It should have all reacted. Shouldn't be any in there, so it's safe to evaporate afterwards. Gently pour that in. So I'll just move this to the side a little bit. You should be able to see at the bottom there, it's coming through nice and clear blue color. So we're going to allow that to filter through, and we'll collect it all at the bottom. And the final step will be to perform evaporation and crystallize the copper sulfate out of there. So to do that, we have an evaporating basin. You place it on top of a heat source. The heat causes any liquid in there to evaporate, and if there's anything soluble within that liquid, it will begin to crystallize. You'll get small crystals. So what we're going to do is, once this is fully filtered through to the bottom, I'm going to take that liquid, I'm going to pop it inside the evaporating basin and then heat it up, and then allow the crystals to form. Now then, I've left that long enough, and as you can see inside the filter paper, we've got this black powder, the copper oxide powder. We call that the residue. The residue is what's left over in the filter paper. Through the funnel, we have filtered out the filtrate. The filtrate is the liquid that passes through the filter paper. So this lovely blue liquid now, what we're going to do is pour it into the evaporating basin. Now when doing crystallization, it's best to heat it for a bit until it begins to evaporate, and then after a short while remove the heat and place it somewhere in the room, usually a windowsill out of the way, to allow the crystals to form. Now what we're really trying to do here is remove off as much of the liquid as possible, and that means that the solution becomes what we call saturated. Saturated solutions means they've dissolved the maximum possible amount of the solute within them. So if I were to evaporate off some of this water, the mixture would become a saturated solution, and then as it evaporates naturally at room temperature, you'll get lovely crystals beginning to form. The reason we heat it up initially and then leave it to evaporate at room temperature is the crystals will have more time to form, and you'll get bigger and better crystals. I've already transferred the copper sulfate solution into the evaporating basin. I've got my Bunsen burner. We're going to light it, and I'm going to place it underneath the evaporating basin to provide the energy to evaporate off that liquid. You can see it's going nicely now. The biggest danger with this stage of the experiment is that as it begins to crystallize out and as the fluid evaporates off, it can spit quite a lot. So again, I am wearing my goggles, and already I can see some copper sulfate is beginning to form. I'll just point that out with a splint here. So just around here, this side, there are some lightly coloured crystals forming. Just there, you might just be able to see them. Again, just pointing out, we've got a lot more crystals appearing on this side now. You can see some appearing there. As you can see, the liquid is almost all evaporated away now. You're getting this film across the top. The copper sulfate is beginning to form. Interestingly, we can show it's copper because if we ignite it, you can see a green flame appears. That is a characteristic colour that copper gives off and emits when it is burned. I'll give this a little bit more of a heating, and then we'll come back to it. And here we have the final product. You can see this blue powder at the bottom. That is the copper sulfate. Because I've heated it up until it fully evaporated, sadly we can't see the actual crystalline structure, but if it had been left on a windowsill, we would actually see small little diamond shapes, clear, looking like glass, but beautiful blue coloured little diamonds. And if we leave it to evaporate over a longer period, they become larger and larger. So there you have it, crystallization following filtration.